going to start our panel discussion now. I'd like to, we're going to have Tom come back up. We're also going to have Brooke Robertson, Project Manager, U.S. DCS Modernization Projects for Momentive Specialty Chemicals, and Rick Ertz, I hope I said that right, it's close enough. It's Dutch, I don't know. No, it's Belgian. I'm even worse. I'm just digging a hole, that's good. All right, MOM Manager for Cargill. And to start off, Brooke, why don't you tell the folks what Momentive does with analytics, so they get a feel for your background.
Well, specifically in my role in interaction, I'm going to speak to it from that perspective mostly. But we're modernizing our DCS systems at several of our large sites within my division. And so as we are doing that, we are implementing best practices in terms of alarm management. We've decided within our company, and it's also, a government initiative also to implement alarm management. So we're going through those activities to help give information to the operators to help them understand what they need to do in abnormal situations to prevent themselves from getting into a further abnormal situation, which could become catastrophic potentially. But then we're also going after opportunities, say like Meridian or APM or AMS, because we're moving with Emerson systems. And so those are some of the applications that work with it that do provide some of those predictive analytics through Device Manager, Machinery Health Manager, Valve Link, and so forth to help us operate smarter within our plants and more efficient, and even change the way that we do some of our calibrations and maintenance on our equipment or during our turnarounds. So in a nutshell, that's briefly how we're using some of it.
Okay, Rick, can you do the same, please?
Yeah, Cargill, of course, is a large company. We have somewhere around 1,600 locations worldwide. So you can imagine that this is very challenging. Now, most of our business is focused on a very basic continuous control and some basic batch, some blending. And in those locations, we, just like Shell, I think, we're using OZPI, and we're using that data to mostly look in the mirror. And the challenge, I think, is that you can use historical data to look through your window, to your front. And that's where we're really starting to look at using that historical data and using some tools like Umetrics and AspenTech stuff to mathematical modeling, and then looking at modeling your facility and predicting what's going to happen. But like I said before, we have 1,600 locations, so this is maybe done in like 60 to 80 to 100 locations. And then last but not least, a couple years ago, we assigned also a person that is looking at this process safety management. I think this is a very, very important part of it, and can we start using those historical information to be more safe? I'm convinced of that.
Great. If you've got a question, please raise your hand. We've got a fellow with a microphone. Anybody with questions? Nobody has questions? Fellow on the complete other side of the room from you. See how fast you can do it.
Sorry for the hiking trip. Dave Allen from GEM Sensors. Questions for Tom. As you went on your journey to get more predictive, how much did you need more sensors and instrumentation? How much did you need those instruments to get smarter? And how much did you just need to collect information that you already had access to, collate it to a place that you could then provide your analytics engine and people to? What's the mix across new, upgraded, and just better consolidation?
Yeah, great question. 85% of what we did was just collating existing data streams. I would say maybe 10, 15% where we actually went out and instrumented some things, added some pi tags, added some end elements. But the vast majority of what we did was focused on collating and making sense out of the enormous amount of rich information that was already in the enterprise. Yep.
Okay. Anybody else want to add to that? Their personal
Well,
experience?
we're also as we modernize our plants, we're not necessarily going after a reinstrumentation effort, but as we implement things like AMS to take advantage of the analytics that exist in there, we're looking at what types of instrumentation do we have in the plants already, and we're using it as an opportunity to help justify some of those projects that if we could purchase a few more here and there, smart devices, it would enable some of our predictive capabilities, where we do have some smart devices already, but the more we have, obviously, the more analytics you're going to be able to do. So we're justifying some of it through our projects that way.
Yeah. Yeah, I guess the one addition I would make, just the comments you made, Brooke, triggered a thought here. The Perditos and the Olympuses and the next set of assets that are going to come on stream over the next decade plus for us have got, probably 4 to 6-fold in terms of end elements, sensors. So they're just much more highly instrumented, driven by, smart devices themselves, but again, the complexity of the environment as well as the equipment requires that level of data intensity. Yeah.
And I'd say even it's helped our sites realize all that they can do by bringing this information in. And so as some of our equipment is becoming obsolete or needs repair, they're actually evaluating it to, hey, let's just completely, if we either just only need an actuator, put in a smart actuator. If we actually need, the whole thing, still we're trying to think in the direction of bringing in some more smart devices to be able to use all the information that you can actually take off of that device to use it online or offline. So it's really challenging our sites to think bigger, and they're actually starting to expand their vision, where when I started working with them, it was very small. They could only just see day-to-day maintenance, run and maintain, and now it's really helping them visualize, hey, we can get predictive, and as we have these things break and fail, let's buy smart, because it's going to get us so much more in the end.
I think, again, if I look to Cargill, we collect so much data at these facilities, and we're not like Shell in this case, which is a lot more safety needed in that area. And if I look at our large core milling facilities in North America, there's 9. We're doing some process strategies and harmonizing our processes. That's the first thing. But then you collect all that data, and all that data comes from instruments. And then how good is that data? How can you turn that raw data into information to make the right decisions? And I think that's the biggest challenge in this whole predictive. If your data is not correct, if you cannot turn it into the right information, forget it, it's not going to work.
Great. Any other questions? You're just perfectly positioned every time.
One other guy with a mic, if there's another ARC person, you can cover both areas.
All right.
Thanks.
Hi, this is Mike Brooks. It's just for Tom.
Yep.
Can you tell me a little bit more about the technology behind the analysis engine? And specifically, how much prediction is it in the engine, or is it just the analysis part? Thank you.
Right, yeah, thanks. Mark, right? Yeah, Mike, sorry. So the core of the analytics engine uses Honeywell technology. So I know Honeywell's here. And that has been a very partnered relationship over the 6-year journey that we've built out the capability. And as I said several times in my presentation, that is just so foundational in terms of what we've been able to do. And, I spouted off the statistics on how many calculations are executed every day, and it's not dependent on someone pressing a button. It's now built into part of our routine engineering surveillance. So a lot of it is analytics, right? I would say that probably 60 to 65% of what we're doing is just a level of analytics. 35% of it is predictive in nature, or it's indicative of conditions that, if left to continue, will likely wind up in production being lost, a restriction building up downhole in a well, et cetera. Right, but we believe, and that was some of the other areas that we're exploring around spectral analysis, around some of the more sophisticated statistical engines. So we're also working right now with SAS as well to really introduce a much higher level of predictive and prescriptive analytics into the business. Yep.
Great. There's a question over here. John, right over there.
Hi, my name is Ibrahim Al Sayed from Siemens. I had a question to Tom as well. If you can comment on how complex was it to integrate the different systems? How did you resolve interoperability issues between different systems? I'm assuming there are different layers and different systems, probably different vendors as well.
Yeah, great question. I'm not sure I'm the best individual to answer that one. So while I led the overall effort for us from start, and I continue to have a role in the evolution of the capability, we did have a very solid set of Shell IT folks that we use. So getting that architecture right, getting the, as you mentioned, the interoperability. A lot of it is coming off of the PI system, but we are actually interacting with our volumes system as well, and our financial system as well. So being able to abstract all of that data, put it into a common warehouse, and then make it available for the analytics engine was a huge effort. Luckily, at the same time, we were embarking on this smart solutions platform, which was all about getting the abstraction layer right so that you could make available the information across a wide range of domains: operational information, engineering information, design information on pieces of equipment. But it was a hefty order, right? It was absolutely a hefty order. But we went into the overall program knowing that was going to be a key success factor. The interoperability issues, the abstraction layer, having access to all of the information was going to be absolutely key. There's a comment here about the quality of the data, and that was something else that we're able to do with some of the Honeywell technology. We do a lot of cleansing, conditioning of the information, throwing out spurious spikes, et cetera, so that, again, we're just reacting to the things that need to be attended to by technical personnel. So thanks for that question.
Anybody else have something to add to that? Okay. Any other questions?
Yeah, this is Michael Barrett with ProSys Incorporated. This is about situational awareness, which is really focused on the operator of these assets. I think the point that Mike Williams brought up about the incidents that we've had in the last 3 years is very important. Dow Chemical in particular has made a very good strategic decision 40 or 50 years ago to use state-based control, which is not an easy decision to make because there's a lot of upfront investment in building these assets. My question for the panel is, how do you justify changing your process to make upfront investments when you know that it's going to pay off in the long term on safer plants and better production?
I'll start off with that one, and I will echo the history of Dow since you brought that up. The reason why Dow chose to do state-based control was actually a board of directors indirect decision. Fundamentally, they looked at statistics like I showed today back 35 years ago, and they said, this is unacceptable. It was unacceptable. And so they found that it was both financially as well as we call the permit to operate. You've heard that saying before. And fundamentally, incidents cost us money directly, indirectly, impacts our employees, our right to exist in our communities, and fundamentally, the statistics, the data was put in front of them. That's why I showed you this today, is to say, look, upper management, and I mean senior management in the corporation needs to understand what is happening, what are the expectations of the regulatory agencies in the various countries, and make sound business and financial decisions. And yes, you are right, the concept of state-based control fundamentally adds 20 to 25% more programming effort, let's call it that, expressed in lines of code, and that code is situational awareness type code to respond to the analytics that are detected. Now, depending on the type of instrumentation, the analytic engines that you have available, that is how you respond to the output from the analytics, is a state-based or process-based control strategy. So it does work. There is a new ISA standard coming out called ISA 106, and it is predicated on the principles of state-based control, primarily directed at automated situational correction. And so I personally am hoping that the standard is brought out and introduced, and people and vendors who support that type of technology are encouraged their clients to use it, because it does attack part of the problem. It attacks the closed loop part of the problem that Tom was mentioning. But you still need to have the predictive analytics up front. You still need to take lots of inferential information in real time, cleanse it, use it, and then the closed loop solution can be state-based control. That's where it fits.
Yeah, and for us, it's similar to what you guys have both said, is that safety is number one, and that's our license to operate. Basically, that's comes from all levels of our organization, and so we did have to go through a justification process of our projects to justify what we're going to spend and how we were going to do it, and part of that was safety based. We had to make some justification and put some evaluations there, but it's the way we operate, and the company supports not just any initiative because it's safety related, but the impact of what it means to the business and how you control, and by control you're keeping your production lines making what you want to make, not running out of control, not running your equipment harder than it should be run, which then could have catastrophic failure of your equipment and all the other things that can ensue. So when you think through the line of what can actually happen when you're not operating to the best way possible and the safest way possible, it wasn't too much of an argument within our corporation.
If I look again, Cargill, all our different diversity of operations, we got palm plantages in Thailand and in Malaysia, and there is no automation. There's zero automation, but still you have the safety. The safety is important. You have to have your standard operating procedures. You have to really look at events, what's happening, behavior of people, and of course the Shells and the big companies like that, they have huge automation in their facilities, but there's the two sides where I think you have to look at. If you want to run your facility safe, and Cargill as well that's number one in our way of operating. Really looks at that. We got 64 crushing locations worldwide. We use hexane. That's our most dangerous, let's say, production. And there's really a lot of standards, and there's no way we can deviate from like safety devices, critical safety devices. That's the only place where we're getting closer to like the oil plants or the refineries.
But I would also contend, as part of the presentation, my challenge is whether you have high or low levels of automation, there are technologies like Tom was presenting, workflow engines, which can be used to invoke a higher degree of discipline, and even with lower levels of automation. But bringing the man, machine, and the methods together, regardless of which one has a higher emphasis, that integration still will help. And it starts from collecting that information, whether it's generated by a human being or a sensor, pulling it together, and then taking some type of action, systematic action.
Yeah, so I would absolutely echo Mike's comment on it isn't all about having highly automated pieces of equipment. Just that integration aspect can really drive a level of rigor and discipline into the business. Many of those assets that are in the Gulf are date 20, 30 years, right? And the level of automation there is actually practically doesn't exist. But through the workflow, through the analytics, through the integration of man, machine, and methods, which is really what we did, we are driving absolutely a level of rigor that did not exist previously. And then just a couple of points here, getting back to the question that was raised. So obviously, as I showed, our approach here was all based on closed loop decision making. That's really what drove the build out of the capability. The notion of situational awareness. So the fact that as alerts and as services get executed, part of the what we've enabled through the system, situationally, the user, the engineer, has access to all the other previous times that alert came up on that piece of equipment, under what state conditions it came up, and they can also look not only at that piece of equipment, but similar pieces of equipment across the entire deepwater fleet, right? So that's part of the situational awareness that we're trying to drive. And then in terms of the value, yes, there was a fairly significant upfront investment, and I guess what I would leave the audience with, I showed you at least in a cartoon fashion the types of returns that we're getting. We had a fairly pretty exhaustive business case that we built out with an understanding of what we thought we could drive in terms of deferment reduction and additional percentage increase in production, et cetera. It's performing, in many ways better than we expected. And we think we're probably only operating at 60 to 70% efficiency in the overall system. So there's more to be gained.
Okay. Other questions? No? Any parting words?
Well, I just say from the work that we've already done and the direction we're headed, our, I guess, target audience is our operators, right? And so the feedback from them already is just operators and maintenance, and the feedback from both of those groups already is very strongly positive about using some of these new systems and capabilities to help them in their day-to-day work and understanding the information in front of them so that they can make decisions before things become abnormal situations, and they can do some predictive maintenance on their systems so they're not running around in, say, cold weather when they don't need to be, So little nuggets of benefits that keep some of those guys happy, it goes a long way. And then from that positive benefit, by word of mouth, it's going to spread to the other operators and just bring more positive momentum to some of these efforts that can be really difficult, really time-consuming, and it's sometimes a culture change. And so these little nuggets starting out small are actually turning into big wins for us.
Yeah, I guess my final thoughts for the group here is to really challenge all of us, industry, that this is absolutely what needs to be done. The proof is in the pudding. The integration of man, machine, and methods can happen. part of my willingness to tell Shell's story and where we're at in our journey is to, again, stimulate the creativity out there amongst the providers, amongst all of industry. I believe it is a capability that is not just an oil and gas capability. It's a capability that transcends all of us in this room, all of the industries that we represent. It is about then standardizing these solutions. We had to do a lot of work to take, a Honeywell solution and a workflow engine and, in many respects, kludge some things together. Having industry standard solutions in this space would be huge. Embedding it into our companies and how we run and operate our business, it is, to me, a license to operate issue and will continue to become, even going forward, a more critical license to operate issue.
I'll add one last pitch here in collaboration with the comments from Cargill. Fundamentally, not all devices are automated out there. Not all of us have the need or desire to have high levels of automation. But the interaction between manual and automated procedure is the data shows that's where the breakdown is happening. You can have various stuff, but that breakdown and taking the information, whether it be generated manually through manual tasks or generated through computers, and taking that information and putting it together in an integrated fashion is the way you diagnose and prevent incidents, or in Shell's case, improve productivity. That's where we're missing. We've done a lot with instrumentation. We've done a lot with automation. Yeah. We've done a lot with operator training. We've got to bring it all together. And Shell showed an example of bringing it together, and I think we need to do more of it in a systematic fashion. Yes, I wish more vendors had integrated solutions, because I'm sure the cost of what Shell did was non-trivial, and lowering that price point to get into that solution would certainly benefit all of us. So I definitely support that.
Maybe as final comment, I'm living in this manufacturing operations management space, so between the whole business and the SAPs of the world and the automation of the world, what we're looking at is standardize or optimize your manufacturing processes, understand your physical processes, do some continuous improvement on these processes, and then decide if you want to automate. If I only have 10, 15 events a day somewhere, you don't need automation to cover that. But if I have thousands of events every hour, then you need to automate. So find that balance. Don't automate just because you want to automate, but automate the right things at the right place for the right reasons and for the right value.
Great. Well, thank you for coming. Thank my panelists. Thank you very much.